In this tutorial, I'll talk about closures, which is a very important concept when you're looking at functional programming. That is, if you're able to pass functions from one place to another in the code as values, you will have to deal with closures. I'll explain what closures are in this tutorial and how we have kind of already seen closures in action even in Java 7. Well, probably not theoretically. There's probably a theoretical computer scientist who's going to come and say, no, that's not closures. But it kind of behaves like one. And just so that we start off with a familiar setting, what I'm going to do is I'm going to create a new class here and demonstrate what kind of happens with the anonymous inner classes concept in Java 7 and how it's very close to closures. So I'm going to create this example class called closures example. I have a main method here. And here I'm going to have an interface called process, which basically has a void process method, right? It just takes in, let's say it takes in an int I. I'm going to have a method here, static doProcess, which takes in a process instance, and then it performs it, p.process. Let's say I pass in an integer I. I'm just going to do process off that I, and this has to be a void. All right, so it just takes in an integer and an instance of this process interface, and it just executes the process for this thing. Now, let's say I want to call this do process over here. Let's say I have an int a equals 10, for example. These are all random values here, so just they don't have any specific meaning. But what I want to do is call the do process method over here and say do process of a and then the process. So I'm going to create a new inner class. I'm going to say new process. It's an anonymous inner class, and I'm going to print the value of whatever is getting passed in. So I'm going to implement this method, which is the process of int I, and I'm going to print println of I. Okay, fairly simple. It is an anonymous inner class which has an implementation of process which just prints that I. This should print 10. No surprises there. If I were to execute this, 10 gets printed. Now here's the thing you can do. Now rather than print I, let's say I want to print I plus some other integers. Let's say I have int b equals 20, right? Now I want to print I plus b. Can I do that over here? Can I say plus b over here? Well, I kind of can, assuming that this is a final if this does not change, right? Now let's say I save this and execute. Now here you see the value shows up fine. Now what's happening here seems to be very simple. Now I have b being used over here, and I'm taking the value over here, so the compiler is basically resolving b to 20, right? This class implementation does not have a b, but the compiler knows that there is a b over here, so it's looking up the value. But if you think about it, it's kind of strange, because when is this method getting executed? It's not getting executed inside the main. It's actually passed into the do process, and it's the do process method that executes the implementation of process. So when this happens, in this line number 22, is there a variable b in the scope? Well, here there isn't, because this method does not have a b. So what's happening here is the Java compiler, or the Java runtime actually, is keeping track of the value of b over here, right? It knows that b has the value of 20. So it knows exactly what to use. Now if I were to do something like this, b equals 40, now notice what happens. I get an error. The error says the local variable defined in an enclosing scope must be final or effectively final. Now, before Java 8, what you had to do something like this was do this, final. You're basically telling the Java runtime that you don't intend to change the value, because as you notice, if I were to change the value of a variable like this, it would give an error. I'm not supposed to change it. So you had to declare that it is a final in the previous versions. But now you don't have to do this in Java 8. This variable is what's considered effectively final, which means that the compiler is saying, hey, you don't have to put a final in there, but I'm going to trust you that you're not going to change this variable. However, I'm still keeping an eye, and if you change that variable, I'm going to complain. You see, that's what it does. When I do change the variable, it complains. It gives me an error. But it didn't really want me to put a final in there. It's like it's saying, I trust you to do the right thing, but I'm going to catch you if you do the wrong thing. So we cannot get this by. We are essentially creating something that does not change. I can, however, read the variable in this inner anonymous class. And if I get passed around, the value of this variable does get passed around. The variable itself does not get passed around. The value, which is frozen, is going to get passed. So when this gets called, you still have the value of 20, which gets printed when this actual method is getting called. All right. So this is similar to the concept of closures that we have in functional programming. Now, if I were to replace this with a lambda expression, what's going to happen is something very similar. Let's say I take this out. And rather than creating an anonymous inner class, I'm going to create a lambda here. It's going to take the I, single argument, and it is going to do a system.out.println of I plus B. Now notice here that this is a lambda expression. I don't need the parentheses here because it's just one variable, one argument. Now notice that this is a lambda expression which is getting passed around, right? This is getting passed to doProcess. Now doProcess is going to accept it and it's going to execute it. When it executes it, it's going to execute this body, system.out.print of I plus B over here. Now where is B coming from? It is coming from this thing called the closure. Whenever there's a lambda expression here and it's using something in the scope, some kind of a variable in the scope, what the Java compiler and the Java runtime do is they kind of freezes the value. It says, okay, this lambda expression is using B and B happens to be 20 at this time, so it's going to freeze the value of 20 along with this lambda expression. So wherever this lambda expression goes, whenever it accesses the value of B, it takes the frozen value of B, because this could go and this doProcess could execute this process somewhere later in time. But by that time, maybe this B has changed to some other different value. Doesn't matter. This process is going to contain that frozen value of B. So wherever that lambda expression goes, that frozen value goes along with it. Okay, so this is the concept of closure. And we also learned the concept of effectively final, which is that when you're using these kind of scoped variables in your lambda expression, the compiler expects it to be effectively final. You don't have to actually have a final here. This is actually final. What the compiler says is you don't have to put a final in there. As long as you can guarantee that it's final, I'm good. Okay, so make sure you don't change any variables that are in the enclosing scope inside the lambda, because it doesn't consider that. It just throws a compiler error. You're not allowed to change those variables.